Okay, so nonlinear simultaneous equations look a little bit like this. They're slightly different in the term that we can't just use the subtraction or addition method. We'll have to use something called substitution. So two things to sort of remember: we're aiming to find the values of x and y, and because we have quadratic terms, so there's x squareds, we will look for a pair of solutions. So we'll find two lots of x's and two lots of y. So let's run through one whole example here. I've got x squared plus y squared is 20 and x plus y is 6. And we can see I can't just take away the x's because they're different terms. One's an x squared, one's an x. Same for y's, one's a y squared and the other's a y. So I can't just subtract them to get rid of them. That wouldn't work. So I've got to think about substituting. Well, I'm going to just label each of the equations, and I'm going to take equation 2 and rearrange it so that I've got just x equals. So in that case I'd have to take away y from both sides, and I get x equals 6 take away y. And I've done that because I can now substitute using that equation there in orange back into equation 1. So I'm going to substitute x equals 6 minus y, which was from equation 2, and I'm going to substitute it into equation 1. So wherever I see x in equation 1, I'm going to replace it with 6 minus y. So instead of x squared, it's now going to be 6 minus y, all squared, plus y squared equals 20. So that equation 1 here has changed from x squared to 6 minus y squared, because that's what we said x was equal to, plus y squared equals 20. And that's the first step we're going to do, and now I'm going to have to expand that bracket out. Well, 6 minus y all squared is the bracket twice, like this. So expanding that bracket out, 6 times 6, 6 times minus y, another 6 times minus y, and minus y times minus y. So I've expanded all the terms out here, timesing each one out. Plus y squared on the end equals 20. Collecting like terms, so I can see that I've got minus 6y, which would give me minus 12y. I can see I've got 2y squared, and I've also got a 36 here, and that's all equal to 20. Carrying that on, I can see I've got a quadratic expression. I've got y squareds, I've got y's, and I've got some numbers. And in order to be able to solve this, I need to make it equal to 0. So I need to take away 20 from both sides. I end up with 16 minus 12y plus 2y squared equals 0. And now I'll be able to solve it. Putting it into the form that we normally see it, just writing the y squared first, then the y, then the number. I've got this here. So we can see we've got 2 in front of the y squared, so I may have to use the AC method. But to help me out a little bit, make it a little bit quicker, I notice all of those coefficients are divisible by 2. So instead of using the AC method, I'm going to divide every term by 2 to give me y squared minus 6y plus 8. And now I can factorise that a little bit easier and quicker than the AC method. So always look out to see if you can do that before heading straight to do the AC method. I need to find two numbers that times together to get plus 8 and add together to get minus 6. So that's going to be 4 and 2, and it's got to make minus 6, so it's going to have to be minus 4 and minus 2. Therefore, when we take it out of the brackets, y must be 4 or y must be 2. And remember back at the start I said because we've got that quadratic here, we're looking for a pair of solutions. So I'm looking for 2 lots of y, which I've got, and I'm now going to have to find 2 lots of x. So make sure you keep these pairs together. So when I've got y equals 4, I'm going to substitute that back into the one of the equations. I'm going to choose equation 2 because that's a lot easier in order to find x. So equation 2 is x plus y equals 6, but with this value of y I found was 4, x therefore must be 2. So one pair of solutions is when x is 2, y is 4, and the other value of y we had was y equals 2. So let's see what that would give us for an x value if y was 2. Again, I'm going to choose equation 2 to substitute it back into because that one's easier. Replace the y with a 2, and therefore x must be 4. So that second pair of solutions is x is 4 and y is 2. It's really important to keep the pairings together. So when y is 4, x is 2, and the other pair we've got is x is 4 and y is 2. And what's quite nice about these questions is that you can check that you're correct. So let's have a look. Does this one work here? If x was 2, I'd get 2 squared plus 4 squared. 2 squared is 4. 4 squared is 16, which equals 20, which gives me that answer there. So I know I've got it correct. Okay, so give this question a go, pause the video and then come back for the solution. So first step I say is always sort of label your equations, and I'm going to use equation 2 to try and get what x is equal to, because if I find what one variable is equal to, I can then substitute it back into the first equation. So I've got x plus 2y equals 2. So to just get what one variable, I'm going to have to take away 2y from both sides. I'm then going to use that and substitute x equals 2 minus 2y from the second equation and substitute it into the first one. Okay, so wherever I see x squared in the first equation, I'm going to replace it with that 2 minus 2y. So instead of x squared here, it's going to be 2 minus 2y all squared plus y squared equals 17. So I've simply replaced what I've put here into the x squared there. I've then got to expand the bracket. So 2 times 2 is 4. 2 times minus 2y is minus 4y. Minus 2y times 2 is minus 4y again. And finally, minus 2y times minus 2y is going to give me plus 4y squared. So that's the bracket expanded, and then write everything that was remaining. Collecting the like terms, well, I've got 1y squared plus another 4, so that's 5y squared. Minus 4y minus another 4y, and then the 4 is remaining on the end, and the 17 here. So I'm resulting it with 5y squared minus 8y plus 4 equals 17. And like I said before, if we've got a quadratic equation, which we have, we've got to get this side equal to 0 in order to be able to factorise it. So I'm going to have to take away 17 from both sides. Okay, notice this one's not as nice. I'm going to have to use the AC method because I've got a number in front of the y squared. So using the AC method, I've got to find a number that times together to get minus 65, but pluses together to get minus 8. Thinking about all the factors of 65 and what would work out, actually what I've got above there, 5 times minus 13 would work out. 5 times minus 13 gives me minus 65, and adding those two numbers together would give me minus 8. So remember 5y squared, we've replaced the y's with what I've just written, the 5y minus 13y and minus 13 on the end. So then minus 8y we've just replaced with this here because that helps us to be able to see how to factorise. We split it down the middle. I can take a 5y out of this first pair here and I'd get y plus 1. And I'm taking away 13 is going to be the factor outside here and I get y plus 1 again. Brilliant, my brackets match up. So one bracket will be 5y minus 13 and the other one will be y plus 1. From that I can take the y values here. This one's quite straightforward, y equals minus 1. This one here, can't quite see it straight away, so I know I've got to make the bracket equal to 0. That means 5y must equal 13 and therefore y must be 13 over 5. So I've done that first stage where I've found the two values of y, and then I'm going to have to substitute them back into the equations in order to find the corresponding x value that goes with them. So we're looking for those two pairs. Let's go for the easier one first. I'm going to substitute into equation 2 because I don't want to have to deal with x squareds or y squareds. Equation 2 says x plus 2y equals 2. So when y is minus 1, we would replace the y with minus 1. X plus minus 2 equals 2. So x minus 2 equals 2. So x therefore must be 4. So one of my solutions is when x is 4, y is minus 1. I'd make sure to underline it, make it clear that's your answer. The other y value we had is 13 over 5. So I'm going to have to do the same. X plus 2 lots of 13 over 5 needs to equal 2. Therefore x plus 26 over 5 equals 2. And so x would be equal to 2 minus 26 over 5, which gives me an answer of minus 3.2. So one of my pairs of solutions is when x is 4, y is minus 1. And the other solution is when y is 13 over 5, x is minus 3.2. Or you could leave it as a fraction as well. So make sure you show clearly your pair of solutions, and again remember you can go back and check whether you've got them right by plugging both x and y in and hoping that you get the results of 17 and 2. Just be aware when you see questions like this where it asks you to give your answers to 1 decimal place and 2 decimal places, it just gives the indication as when you get to your quadratic and you need to factorise, you'll probably have to use the quadratic formula given that the answer will be a decimal and you'd have to round it. So just be aware that when you see a simultaneous equation like this, where it asks you to give your answer to 1 or 2 decimal places or to some degree of accuracy, you'll probably end up using the quadratic formula when having to factorise. The final sort of example is the questions aren't as obviously given as before. You could give a question like this where it's actually a nonlinear simultaneous equation sort of in disguise, if you like. You've got a circle with equation x squared plus y squared equals 100, and you've got a straight line with the equation x minus y equals 2. And it's saying find where the graphs intersect, so where both lines are equal to each other, here and here. So this here actually we've solved by using the simultaneous equation method. So with this one here, we would again do the simultaneous equations. So I will show you how to do that. Again, equation 2, I want to just get what x is equal to, so that must be 2 plus y. I then use that to substitute into equation 1. X squared would now be 2 plus y all squared. Expanding the bracket, I would end up getting 4 plus 4y plus y squared. Bringing all the like terms together, I can see I've got 2y squared plus 4y plus 4 equals 100. And I've got a quadratic at this point, so I need to make it equal to 0 in order to be able to factorise, which will give me minus 96 on the end. I look to see whether I can get rid of this coefficient of 2 because it makes factorising a whole lot easier, and I can because all the numbers are divisible by 2, so I can make it a lot easier for myself by dividing everything by 2 and getting y squared plus 2y minus 48 equals 0. Continue by factorising, trying to find the values of y, times together to get minus 48, add together to get 2. It's going to be 8 and 6, and I need the 8 to be plus and the 6 to be minus in order to make plus 2y. That gives me a value of y is 6, or y is minus 8, and we find the corresponding x values. So y equals 6, again I'm going to use equation 2 because that's way easier. X minus 6 therefore needs to be 2 because I've replaced the y with this y here, 6. Therefore x must be equal to 8, and when y is minus 8 I get x minus 8, so be careful when subbing that in. X plus 8 equals 2, therefore x must equal minus 6. And so for this one here, it's quite nice, therefore I can put my solutions as coordinates. Coordinates are x, y, therefore the x for this one was 8 and the y was 6. And for the one here, I had minus 6 for x and minus 8 for y. And that sort of makes sense. If I have a look visually on my graph, this point here is going to be 8, 6. That sort of works with it being less than 10 and less than 10 here. Brilliant. And then this coordinate here, yeah, it seems about right for it to be minus 6, minus 8. So that works out there. So writing your answers as coordinates, because we've got an x value and a y value, and we've got 2 points that intersect. So a similar example for you to have a go at. Pause the video, give it a go, and then watch the solution. So I'm going to label the equations 1 and 2. I've got to find where they intersect, which is here and here on the graph. And we can do this simultaneously. So it's just a simultaneous equation sort of hidden within a graphical scenario. Rearranging equation 2 to get one of the variables to be the subject. I'm going to plus y on both sides, and I would get x equals 1 plus y. I'm therefore going to do as we normally do and substitute it into equation 1. So instead of x squared plus y squared equals 5, the x is going to be replaced with 1 plus y, and that's all got to be squared. Expanding the bracket would give me 1 plus 2y plus y squared, and then I've got that y squared on the end equals 5. Collecting all the like terms, I've got 2y squared plus 2y plus 1 equals 5. And because I've got now a quadratic term, I want to get it all over to one side to make it equal to 0 so that I can factorise, which means I've got to take away 5 from both sides. Got a coefficient in front of the y squared. Can I get rid of it? Yes, I can divide by 2 for all the terms. And now it's just a case of factorising. Y and y, they've got to times together to get minus 2, add together to get 1. That's going to have to be 2 and 1 plus 2 minus 1. So my two values of y are y equals 1 or y equals minus 2. And remember, we're going to have to therefore find the x values that go with those y values. I'm going to use equation 2 because it looks easier. X take away 1 equals 1, therefore x must be 2 for this one here. So that pair of solutions is with the x, y coordinates, x is 2, y is 1. And for this one here, when y is minus 2, x minus y equals 1, well y is now minus 2. So remember, replacing the y with minus 2. A minus and a minus make a plus when they're next to each other. So therefore x must be minus 1. So that gives us a coordinate of x, which is minus 1, and y, which is minus 2. And I'm just going to go and have a look at the graph. Does that seem about right? Well, yeah, this point could be 2, 1. And this point here, minus 1, minus 2, seems about right as well. So I found those two solutions.